Welcome to lesson 6.4 and the start of lesson 6.2 on hyperbolas and parabolas. So we're going to finish off hyperbolas and we'll start a little bit on parabolas today. So we're going to be looking at writing equations of hyperbolas. We're going to complete the square with hyperbolas, which is a little tricky, so that's going to take some practice. And we're going to maybe start graphing some parabolas as well. So first thing, let's review the format of a hyperbola equation. Some things to notice here when I'm looking at it. I have both x squared and y squared in it, and I have a subtraction between them. And that subtraction is what's creating a hyperbola instead of an ellipse. Normally, we're equal to 1 on the other side. Since I have 144 on that right-hand side, I'm going to start by dividing by 144. Somewhat easily. Okay, so I'm going to divide by 144 on all three parts. So I end up with x plus 1 squared. And I'm going to simplify 9 over 144, and I'm just going to math frac that in my calculator. It's going to be 1/16. And 36 over 144, when I math frac that, is 1/4. So then my center, to determine my center, I'm looking at this piece and this piece. I want to do the opposite of each of those. So my center is going to be at -1, +2. This particular one, because the x is the positive and the y is the negative, is going to be a left and right kind of hyperbola. So my transverse axis is going to be along the x-axis, and in this particular case, it's moving 4 in each direction for a total of 8 units. The conjugate axis, it goes 2 in each direction for a total of 4 units. Vertices and foci I'll do in a moment. Let's start graphing some of this. -1, +2. Well, -1, +2 is right here. Then I'm going to head 4. 1, 2, 3, 4. Come on. 1, 2, 3, 4. 1, 2, 3, 4. That's because the square root of 16 is 4. And up and down 2 because the square root of 4 is 2. That makes my lovely rectangle. Then I'm going to do my asymptotes as best as I can. If you have a ruler at home, it's awesome to use a ruler. And next thing I'm going to do is my 2 branches of my hyperbola. One branch on this right-hand side, and one branch on the left-hand side. So those 2 green points that I just plotted, those are my vertices. One happens to be at 3, 2, and the other is at -5, 2. Next, I think I'm going to do the asymptotes and then come back to the foci. I know, I'm crazy today. So my slope here is a +1/2 and a -1/2. And since I'm not centered at the origin, I'm going to have to write it in point slope. So a reminder, point slope is, let's see, y minus k is mx minus h. And the point I'm going to use is the point that both of those lines go through, which is right there at that center. How convenient that we have it listed out in our information as well. So y minus 2. Notice I'm putting a plus or minus. That's because I'm writing both equations at the same time. Just like that. And next I want to find the foci. Now our foci are going to be located, oh, goodness. 4 squared plus 2 squared is equal to f squared. 16 plus 4 is equal to f squared. At this moment, you're going to notice that those numbers are the same as in our denominators. That is not a coincidence. F is the square root of 20 plus or minus, which means we're talking about plus or minus 2 root 5. Now, we're not going to write our foci as just equal to that because we always write it as a coordinate point. And we're going to move that distance from the center along the x. The reason we're moving along the x is because it's a left-right hyperbola. So I'm going to take that 1, that x coordinate, and add plus or minus 2 root 5 to it. What was it? Positive 2? Positive 2. Sorry, I forgot for a moment. I could have just looked at vertices. Oh well. Alright, so that's all stuff from background knowledge. But again, I just wanted a refresher to make sure we were all on the same page before we go further. Now, write the equation of the hyperbola with the following characteristics. So now what I'm doing is I'm giving you a set criteria, and I want you to actually write the equation that goes with it. So I'm going to actually make myself a little, hold on. There we go. That doesn't have to be perfect, but that one was really bad. So vertices at positive 6 and negative 6. So the fact that they're like that, that's telling me my center is right here at 0, 0. Since the vertices are along the x from that 0, 0, I know we're like this and like this. Yeah, don't use the mouse, it's not a good idea. Which also tells me that I'm going to have, x squared minus y squared. Now I just need to fill in the denominators. I'm going to have equals 1 on the other side. Now I'm headed from my center to 6, so this distance here is 6, which means my denominator will be 6 squared, or 36. I put it under the x because it's how far I'm traveling left and right. Now I need to do the foci. I know that that 6 squared plus whatever's going to go in this box, and I'm just placing a box there for a moment as an unknown. You could also use a variable if you wanted to. 6 squared plus something is going to give me 2 root 10 quantity squared. So 6 squared is 6 squared is 36 plus something is going to give me 40. Well, that something is 4. So that's going to be 4 right there. Final answer. All right. You try, pause the video now and try problem B. Did you try it? Okay. So here, the same idea happening. I've got 4 and negative 4. So let's see that shape and that shape happening. And my foci are like there and there. So since this is an up and down one, I'm going to have y squared on the top minus x squared is equal to 1. Now my y squared, that distance is 4, so 4 squared is 16. And I know 16 plus something has to give me 6 squared, or 36. 16 plus something is 36. That something is 20. And you can see it if I just subtract it. Okay. All right, C, vertices at 0, negative 4, and 6, comma, negative 4. I'm no longer centered at the origin. Okay. So 0, comma, negative 4.